Hey everybody, I am Nguyen-Tu, and this is Lab 1 of Physics 2212. The purpose of this lab is to determine approximately how much excess charge is on one piece of charged clear tape. In this lab, I will be using Newton's second law and the momentum principle. Newton's second law is force equals mass times acceleration that tells us the acceleration of an object is directly related to how much force is applied to the object. The momentum principle tells us that in an isolated system, momentum is conserved for any interaction between two objects. Also in this lab, I will be using Coulomb's law and the electric field formula for a single point charge. Coulomb's law says that the electric force between two charged particles is equal to 1 over 4 pi epsilon 0 times the first charge times the second charge divided by the distance between the two charges squared times the directional unit vector that points from the source charge to the charge that the force is applied to. This is also equal to the first charge times the electric field of the second charge, where the electric field of a point charge is the same as that of the electric force formula, except that there is only one charge in the numerator. To complete this lab, I will create U-tapes, determine the sign of the U-tape's charge by observing its interactions with 4 different objects, measure the separation distance between 2 U-tapes repelling each other, and then estimate the charge of the U-tapes by modeling the 2 repelling U-tapes as 2 point charges and then as 2 line charges. The main result of this lab is that the U-tape was determined to be positively charged in the experiment with a charge of 1.18321 times 10 to the negative 8 coulombs in Model 1 and a charge of 2.51057 times 10 to the negative 8 coulombs in Model 2, which is 2.12183 times Model 1's estimate. For this lab, I made 2 identical U-tapes of length 0.19 meters, width of 0.019 meters, and a mass of 0.00019 kilograms. When hung as shown in Figure 3, the U-tape attracted to my hand, the neutral charged planar, and the negatively charged pen. Placed as shown in Figure 4, the U-tape repelled against an identical U-tape of similar charge. Therefore, it was concluded that the U-tape is positively charged. For Model 1, the system is the top tape and the surroundings is the bottom tape. For assumptions, I assume 1. Each tape can be represented by a single point at the center of the tape with all of its charge located there. 2. The only forces acting on the top tape is gravitational force and electric force that perfectly balance each other out. And 3. Both tape have the same net charge. Underlying assumption 2, I am assuming air resistance is negligible with everything else in the surroundings besides the bottom tape having a negligible effect on the top tape. Shown here is the main code for Model 1 with the physical constants and variables on the left, the function that calculates the electric field of a charged particle at a given location on the bottom left, and the calculations for the model on the right. Of note, the estimated charge was calculated by rearranging the equation of the electric force to solve for Q under the assumptions of the model. Here's the code for the graphics of Model 1 with the code that helps create the key on the bottom left and the code that creates the visuals on the right. Of note, the electric field arrow is not to scale with the other vectors and is offset in the z direction so that it is visible after being shrunk. For Model 2, the system, surroundings, and assumptions are the same as in Model 1 except for the first assumption, which was changed such that each tape can be represented by a line of point charges of evenly distributed charge. Shown here is the main code for Model 2 with the physical constants and variables on the left, the same electric field function as in Model 1 on the top right, and the function that creates the line of charges that represent the top and bottom tape on the bottom right. Of note, the difference factor between the estimated electric charge found in Model 1 and the estimated electric charge in this Model 2 was found through trial and error. On the right is the remainder of the main code for Model 2. This code calculates the electric force on the top tape due to the bottom tape by adding up all the forces from each point charge that makes up the bottom tape as they interact with each point charge that makes up the top tape in the model. Here's the code behind the visuals of Model 2. Like Model 1, the electric field vector arrow representations are shrunk and not to scale with the other visuals. For possible sources of error in this lab, the net electric charge might not be the same for both U-tapes as was assumed, which would affect the separation distance found and thus the estimated charge results of the lab. Also, the pen was not confirmed to be negatively charged, which could affect the lab by flipping the sign of the electric charge analyzed. With Figure 4, the tension force on either end of the top tape might not be negligible, which could lower the separation distance. For Model 2, the electric charge might not be evenly distributed across each tape as was assumed, which would cause the estimated charge to be lower or higher than it actually is, depending on the actual distribution of charge across each tape. The estimated value of the charge is different between Model 1 and Model 2 because all the charge for each tape was concentrated into a single point charge with one separation distance in Model 1, while the charge is evenly distributed in Model 2 with different separation distances between the charges of the top and bottom tape. These differences in separation distance in particular had a large effect on the estimated charge because separation distance is squared in the denominator of the electric force formula. Between the two, the estimated charge found in Model 2 is likely to be closer to the real value because tape is made of more than a single point. If the signs of electrons and protons were reversed, the relationships between like and different charges would be the same. As a result, nothing would change about the relationships between the U-tapes and the other charged objects in the experiment except for the name of the charge flipping from negative to positive and vice versa.